So our next question is differentiate with respect to x tangent square x. Solution: let y is equal to tangent square x. So by applying the process of differentiation by first principle, uh, changing this y to y plus delta y, and this tangent square x will become tangent square x plus delta x. Now delta y will become tangent square x plus delta x minus y, and as y is equal to tan square x, so putting the value of y tan square x here, this will become tan square x plus delta x minus tan square x. Now we'll move towards simplification step. So that will become by using a square minus b square. So that will become actually a plus b and a minus b. So here we have tan x plus delta x plus tan x into tan x plus delta x minus tan of x. As we discussed earlier, that we have to simplify only those part of this one which is not giving an answer actually. So when we will move towards a limiting step and applying limit delta x approaches to 0, so that will become tan x plus tan x, which is 2 tan x. But when we apply limit here, that will become 0. So here we have tan x minus tan x, which is 0 actually. So we have to simplify this one particularly. So that will become sin x plus delta x divided by cos x plus delta x minus sin x over cos x. So this is actually unaffected, tan x plus delta x plus tan x, and by simplifying this one, we take an LCM cos x plus delta x and cos of x. So this will become sin x plus delta x cos x minus cos x plus delta x into sin of x. And now this is tan x plus delta x plus tan x, and this cos x plus delta x cos x, which is actually denominator of this part, which is here. And by merging this formula sin x plus delta x cos x minus cos x plus delta x sin x, by using this result sin alpha minus beta sin alpha cos beta minus cos alpha sin beta. So here we have, this one is actually alpha, sin alpha cos beta minus cos alpha sin beta. So that can be converted into sin alpha minus beta. Here x plus delta x is an alpha and beta is x. So this is actually sin x plus delta x minus x. This x minus x will be cancelled out, and dividing both sides by delta x, that will become delta y by delta x, tan x plus delta x plus tan x cos x plus delta x into cos of x, and this is sin delta x and dividing delta x here. Taking limit delta x approaches to 0 on both sides, this will become limit delta x approaches to 0 delta y by delta x is dy by dx, and when we'll apply limit delta x approaches to 0 on right hand side, so limit will apply actually like limit delta x approaches to 0 tan x plus delta x plus tan x divided by cos x plus delta x into cos of x, and limit delta x approaches to 0 sin delta x divided by delta x. So actually limit will apply on both of these two parts explicitly or separately. So this delta x will become 0. We have tan x plus tan x cos x plus this will become 0 by applying limit cos x into cos of x, and this whole thing, when we will apply limit, this is actually this part, so that will become 1 by using the theorem. So we have dy by dx is equal to 2 tangent x divided by cos x into cos x will become cos square x, and that can be written as 2 tan x, and 1 over cos square will become secant square x. And by verifying the result of tan square x, differentiation of tan square x, so by using first our power formula 2 tangent 2 minus 1, and then derivative will apply on trigonometric function which is tangent x. So this is 2 tangent x, and the derivative of tangent x, as we proved in our basic formula, that will become secant square x. So This is actually verified result of derivative of tan square x will become 2 tangent x into secant square x. Now the next part is differentiation of square root of tangent x. Solution: let y is equal to square root tangent x, and by applying the process of differentiation by first principle, first step is y plus delta y, that will become tan x plus delta x square root, and delta y will become under root tangent x plus delta x minus y. And as y is equal to square root tangent x, by putting the value here, that will become square root tangent x plus delta x minus square root tangent x. So next we will move towards simplification step. So that can be simplified by rationalizing this square root tangent x plus delta x minus square root tangent x. So multiplying and dividing by square root tangent x plus delta x plus square root tangent x, dividing by square root tangent x plus delta x plus square root tangent x. And by using the result a minus b and a plus b, this will become a square minus b square. So here we have square root tangent x plus delta x whole square minus square root tangent x square, and dividing by this denominator will be as it is. This square root will be cancelled out by square, and we have delta y is equal to tan x plus delta x minus tangent x, dividing by square root tan x plus delta x plus square root tan x. This can be written as, this denominator will be as it is, unaffected tan x plus delta x plus square root tangent x, and this numerator will be or can be written as sine x plus delta x divided by cos x plus delta x minus sine of x dividing by cos of x. Again, the same explanation of this step, that is, when we will move towards the step when we apply limit delta x approaches to 0, this part will become tan x plus tan x, and giving an answer square root tan x multiplied by 2. But when we will apply limit here in numerator, delta x approaches to 0, that will become tan x minus tan x, which is actually 0, and 0 dividing by something will become 0. So we will have to simplify this thing to get an answer. So we will shift this tan x plus delta x minus tan x into sine and cos expression. So this denominator will be as it is, 1 over square root tan x plus delta x plus square root tan x, and this is simplifying by taking an LCM. Again, using the same result, sine alpha cos beta minus cos alpha sine beta, this will become sine alpha minus beta. Here this is actually alpha and this one is actually beta, so sine alpha cos beta minus cos alpha sine beta will become sine alpha minus beta. Denominator will be unaffected, will remain same in both of these two expressions, and delta y will become 1 over square root tan x plus delta x plus square root tan x, and here x and minus x will be cancelled out. We have sine delta x, and in denominator cos x plus delta x into cos of x will be as it is. Dividing both sides by delta x, delta y by delta x, 1 over tan x plus delta x plus tan x, and 1 over cos x plus delta x into cos of x, and sine delta x dividing by this delta x. Taking limit delta x approaches to 0 on both of sides, so left hand side will become dy by dx when we will apply limit delta x approaches to 0, and on right hand side this delta x will become 0. We have 1 over square root tan x plus square root of tan x, and when limit will apply on this part, this delta x will become 0. We have cos x into cos of x, and when we apply limit here, limit delta x approaches to 0, sine of delta x dividing by delta x, so that will become actually 1. So this is 1 by using this theorem. And finally we have 1 over 2 times square root tan x into cos of x, and this cos of x will become cos square of x, and derivative of square root tan x will become secant square x dividing by 2 square root tangent x. This 1 over cos square will become secant square x. And again, verifying this result, d by dx square root of tangent x. So applying derivative by using power formula, we have 1 by 2 square root tan x, and then derivative will apply on tan of x. So this tangent x will give secant square x, differentiation of tangent x, and in denominator that is 2 times square root of tangent x, which is exactly the same thing by applying differentiation using first principle. So we have derivative of square root of tangent x is equal to secant square x dividing by 2 times square root of tangent x.